Bougainville, Solomon Islands, November 1, 1943, 0545 hours, and Colonel Takeshi Iwasa, commanding the 23rd Infantry Regiment's Assault Battalion, crouches in jungle undergrowth 800 meters from American defensive positions along the Torquay River, confident that his 650-man force can overrun the thinly held marine perimeter before American artillery batteries, positioned 3 kilometers inland and dependent on slow field telephone communications or runner-based fire requests, can deliver effective supporting fire to the defenders. Iwasa has studied American defensive tactics extensively, noting their reliance on artillery support that typically requires 5 to 10 minutes from initial fire request to first rounds impacting. A delay as rapid assault tactics are designed to exploit by closing with American positions so quickly that artillery becomes unusable without risking friendly casualties. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. What Colonel Iwasa cannot possibly know, what no Japanese officer could imagine despite their intelligence on American equipment and tactics, is that the Marine riflemen defending the Torquay perimeter carry portable SCR-300 walkie-talkie radios weighing just 38 pounds that allow forward observers to communicate directly with fire direction centers in real time, coordinating artillery fire with precision and speed that will bring 105mm shells crashing down on his assault formations within 90 seconds of contact, not the 5 to 10 minutes his planning assumes, and within 20 minutes, Iwasa will watch his carefully planned assault shattered by artillery fire so perfectly coordinated and rapidly adjusted that survivors will describe it as shells that follow us like hunting dogs. The moment when Japanese infantry tactics designed to exploit communication delays encountered American technology that eliminated those delays entirely. The confidence of Japanese forces in their ability to close with American positions before artillery becomes effective stems from extensive combat experience throughout the Pacific Campaign, where traditional communication methods created exploitable delays in fire support coordination. Major Kenji Hatanaka, operations officer for the 6th Division, has analyzed dozens of engagements where Japanese forces successfully penetrated American defenses by moving faster than artillery could respond, noting that conventional fire request procedures, requiring observers to relay coordinates through field telephone networks or dispatch runners to artillery command posts, typically consumed 5 to 15 minutes before first rounds arrived. This time lag, combined with the additional minutes required to adjust fire onto moving targets, created tactical windows that aggressive Japanese infantry could exploit through rapid movement and infiltration tactics. Colonel Iwasa's assault plan reflects sophisticated understanding of American defensive doctrine and its vulnerabilities. The attack will advance in 3 waves. The first wave of 200 men will close rapidly to within 100 meters of American positions before initiating final assault, moving too fast for artillery adjustment and getting close enough that American gunners cannot fire without risking their own troops. The second wave of 250 men will exploit any penetrations, pouring through gaps before Americans can reposition reserves. The third wave of 200 men constitutes the exploitation force that will turn tactical breakthroughs into operational collapse of the American perimeter. The entire plan depends on speed, covering 800 meters of jungle terrain in less than 10 minutes, accepting the casualties from direct fire weapons but arriving at American positions before artillery can be effectively employed. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now back to the story. Japanese infantry tactics for assaulting defended positions emphasize aggressive movement, infiltration through gaps in defensive lines, and willingness to accept casualties during approach phases in exchange for achieving close combat where Japanese advantages in night fighting and hand-to-hand combat can be decisive. Captain Hideaki Yamashita, commanding the assault battalion's lead company, has drilled his men in rapid advance techniques, moving in dispersed formations that limit casualties from any single artillery shell, using terrain features to mask movement from observation, and maintaining momentum regardless of losses. His soldiers understand they're racing against American artillery response time, that survival depends on closing with enemy positions before the inevitable artillery barrage begins. The American defensive positions along the Torquay River represent standard Marine Corps doctrine for holding key terrain against numerically superior enemy forces, dispersed rifle companies occupying mutually supporting positions, crew-served weapons sighted to create interlocking fields of fire, and immediate access to artillery support from the 12th Marines' 105 mm howitzer batteries positioned to cover the entire perimeter. First Lieutenant Robert Hayes, commanding 2nd Platoon of Company E, 3rd Battalion, 3rd Marines, occupies positions his men have improved over 3 days, shallow fighting holes with overhead cover, cleared fields of fire extending 200 meters into jungle, communications wire connecting his position to company headquarters. What distinguishes Hayes' position from defensive positions in earlier Pacific campaigns is the SCR-300 radio carried by his forward observer, Corporal James Martinez. The SCR-300 walkie-talkie radio represents revolutionary advancement in tactical communications, transforming infantry forward observers from passive positions dependent on wire communications into mobile artillery coordination centers capable of directing fire while moving with assault troops. Technical Sergeant William Chen, communications specialist for the 12th Marines, understands the SCR-300's capabilities intimately, frequency modulated, FM, transmission providing clear voice communications up to 3 miles in jungle terrain, battery power sufficient for 8 hours of operation, 35 pounds of electronic equipment plus 3-pound battery pack, creating a system that, while heavy, remains man-portable. The radio operates on 40 to 48 MHz frequency range, using FM modulation that proves far more resistant to interference and jamming than older AM systems, providing reliable communications even in dense jungle that previously made radio coordination impossible. What makes the SCR-300 revolutionary is not any single technical specification but rather the integration of sufficient range, acceptable weight, and voice quality transmission into a system that forward observers can carry into combat while maintaining continuous real-time communications with artillery fire direction centers. Earlier radio systems required either large vehicles to transport them or provided such limited range and poor voice quality that they proved impractical for forward observer use. The SCR-300, introduced in late 1942 and reaching Pacific units throughout 1943, finally delivers on the promise of radio-coordinated artillery that military theorists had envisioned for decades but technology had been unable to achieve. Corporal Martinez, having completed forward observer training at Camp Pendleton before deploying to the Pacific, carries his SCR-300 as naturally as riflemen carry their M1 Garins, the radio's weight distributed through improved harness design that makes the 38-pound system tolerable during extended operations. His training emphasized speed and precision, identifying targets, estimating ranges, transmitting fire missions using standardized brevity codes, and adjusting fire through systematic corrections. Martinez knows his fire requests reach the 12th Marines Fire Direction Center within seconds, that trained fire direction officers calculate firing data while he's still talking, and that gun crews can put rounds downrange within 90 seconds of his initial transmission, response time impossible with any previous communication system. The artillery fire direction procedures that complement the SCR-300's communications capability represent equally significant advancement in coordinating indirect fire. Captain Thomas Anderson, Fire Direction Officer for the 12th Marines 2nd Battalion, operates a sophisticated system that translates forward observer reports into precise firing data for multiple gun batteries. The Fire Direction Center employs mechanical computers, detailed survey data, and standardized procedures that calculate gun elevations, powder charges, and fuse settings within seconds of receiving target coordinates. The integration of radio communications with improved fire direction procedures creates multiplicative effects. Radio eliminates communication delay, improved fire direction reduces calculation time, and standardized procedures ensure every battery can respond to any observer's requests without confusion or coordination failures. What distinguishes American artillery doctrine in 1943 from earlier practices and from enemy equivalents is the emphasis on centralized fire direction combined with forward observer autonomy. Any qualified forward observer can request fire from any available battery. Fire direction centers coordinate multiple observers and multiple batteries simultaneously, and the system operates on the principle that artillery exists primarily to support infantry operations rather than as independent arm requiring lengthy planning and preparation. This doctrinal approach, combined with technological enablers like the SCR-300, creates artillery responsiveness that enemies trained on different systems cannot anticipate or counter. Japanese military intelligence regarding American artillery capabilities focuses primarily on weapon characteristics, range, rate of fire, ammunition types, while failing to comprehend the revolutionary impact of improved communications and fire direction procedures. Intelligence summaries circulated to Japanese commanders note that American 105mm howitzers possess excellent range and accuracy, that American forces typically enjoy artillery superiority in terms of ammunition availability, but these reports treat American artillery as conventional indirect fire weapons requiring traditional communication and coordination. No Japanese planning document from 1943 anticipates that American forward observers can coordinate artillery fire in real time using portable radios, that response times have been compressed from minutes to seconds, or that this technological advantage fundamentally alters tactical calculations about assault timing and movement rates. At 0548 hours on November 1, Colonel Iwasa gives the order to commence the assault, and 650 Japanese soldiers begin advancing through jungle darkness toward American positions 800 meters distant. The lead wave maintains good noise discipline, moving carefully through thick undergrowth, using practiced infiltration techniques to close the distance while minimizing detection. Japanese doctrine calls for remaining undetected until reaching assault distance, then attacking with maximum violence and speed to overwhelm defenders before they can react effectively. For the first 5 minutes, the advance proceeds according to plan as Japanese infantry navigate through jungle terrain and close to within 500 meters of American lines. Lieutenant Hayes, occupying his fighting position in the pre-dawn darkness, receives first warning of the Japanese assault at 0553 hours when listening posts report movement sounds at 400 meters. Hayes immediately alerts his platoon and notifies company headquarters of possible enemy contact, following standard procedures that assume he is perhaps 5 to 10 minutes before Japanese troops reach assault distance. But Hayes takes an additional step that commanders in earlier campaigns could not. He directs Corporal Martinez to prepare for immediate fire mission, positioning the forward observer where he can observe likely Japanese approach routes and maintain continuous radio contact with the 12th Marines. Martinez, adjusting his SCR-300's frequency selector to the pre-assigned fire support channel, establishes contact with Fire Direction Center within seconds. Red Dog, this is Romeo 27, fire mission, over. The transmission, clear and free from the static that plagued earlier radio systems, reaches Captain Anderson's Fire Direction Center 3 kilometers away with perfect clarity. Anderson acknowledges immediately, Romeo 27, Red Dog, send your mission, over. The entire exchange consumes perhaps 10 seconds, communication speed impossible with field telephones requiring multiple relay stations or runners who might take 5 minutes to traverse 3 kilometers. Martinez transmits his initial fire request using standardized format that fire direction personnel have drilled to automatic proficiency. Grid 745823, enemy infantry in the open, approximately 400 troops, request immediate suppression, will adjust, over. The coordinates reference pre-plotted reference points that both Martinez and the Fire Direction Center share on identical maps, eliminating the time-consuming process of describing locations through terrain features or lengthy coordinate readings. Anderson's team calculates firing data for 2 batteries, 8 105mm howitzers, within 30 seconds, the mechanical computer's processing range, deflection, and elevation data, while Anderson selects high-explosive shells with variable time fuses for airburst effects against troops in the open. At 0554 hours and 20 seconds, barely 90 seconds after Martinez transmitted his initial fire request, the first 8 105mm shells leave their tubes with the distinctive crack of artillery discharge. Colonel Iwasa, moving with his assault troops at the 400-meter line, hears the sound of distant artillery fire and experiences momentary satisfaction that his troops are making such rapid progress. American artillery typically didn't fire until after initial contact, and his forces aren't yet at assault distance. His experience tells him these shells are likely harassment fire aimed at suspected assembly areas, that his moving troops will avoid the beaten zone through speed and dispersion, and that even if shells land near his position, his men can continue their advance before American gunners adjust fire onto the actual target. The shells, traveling at supersonic velocity, traversed 3 kilometers of airspace in approximately 20 seconds. Martinez, watching the likely Japanese approach routes through darkness broken by false dawn's first light, sees muzzle flashes from the artillery position, mentally calculates time of flight, and prepares to observe shell impacts for adjustment. The first 8 rounds impact at 0554 hours and 40 seconds, detonating an airburst pattern 30 meters above ground at precisely the location Martinez specified. The variable time fuses, set for optimal airburst height, function perfectly, creating spherical fragment patterns that sweep the jungle floor where Japanese troops are advancing. The effect on Colonel Iwasa's lead wave proves devastating and completely unexpected. Artillery fire, which Japanese tactical planning assumed would not arrive for several more minutes, materializes less than 2 minutes after American forces detected the assault. The airbursts, positioned perfectly over the Japanese formation through precise fire direction calculation, rain fragments down on troops who expected to have several more minutes of uncontested advance. Iwasa personally witnesses approximately 30 soldiers in his immediate area killed or wounded by the initial volley, casualties occurring before his assault even reached the halfway point to American positions. The psychological impact matches the physical casualties as soldiers who expected to exploit American artillery's slow response discover that fire support arrives with impossible speed. Martinez, observing the initial impacts, immediately transmits adjustment, Romeo 27, drop 50, right 50, fire for effect, over. The correction, based on observing shell bursts relative to actual enemy position, takes less than 5 seconds to transmit. Fire Direction Center acknowledges and begins recalculating firing data for the adjusted target location. The second volley launches at 0555 hours and 10 seconds, with shells impacting at 0555 hours and 30 seconds, barely 1 minute after the first volley. This second barrage lands directly on the densest concentration of Japanese troops, creating casualties that exceed anything Colonel Iwasa has experienced from American artillery in previous engagements. The rapid adjustment of fire, impossible with traditional communication methods requiring runners or field telephone relay, demonstrates the SCR-300's revolutionary impact on artillery effectiveness. Earlier in the war, forward observers detecting that initial rounds missed their target might require 5 to 10 minutes to communicate adjustments through telephone networks, with additional minutes for recalculation and firing. Martinez achieves the same adjustment in under 1 minute total elapsed time, creating artillery responsiveness that transforms indirect fire from an area weapon of limited precision into a responsive tool that can track and destroy moving targets. Captain Yamashita, commanding the lead assault company, attempts to maintain momentum despite the artillery fire, shouting orders for his men to continue advancing rapidly to escape the artillery-beaten zone. Japanese doctrine emphasizes that stationary troops present easier targets than moving forces, that aggressive forward movement eventually closes with enemy positions where artillery cannot be employed, and that accepting casualties during approach phases remains preferable to stalling under fire. His soldiers respond with disciplined courage, continuing to advance despite losses, trusting that speed will carry them beyond American artillery's reach before casualties become unsustainable. Martinez, maintaining continuous observation and radio contact, calls subsequent adjustments as Japanese troops continue their advance, Romeo 27, add 100, same deflection, troops in the open, continuing fire for effect, over. The transmission goes out at 0556 hours, with adjusted fire impacting at 0556 hours and 40 seconds. The artillery, rather than being a static defense that Japanese troops can move through or escape, follows the advancing enemy formation with adjustments that keep shells impacting on target despite movement. The effect proves psychologically devastating as Japanese soldiers realize that American artillery is tracking their advance, adjusting fire to follow their movement, responding with speed that eliminates any opportunity to escape the beaten zone through rapid movement. Lieutenant Hayes, monitoring the radio traffic while preparing his platoon for possible close combat if Japanese troops reach his positions, recognizes that the battle is being decided by artillery coordination he could not have achieved just months earlier. In previous campaigns, forward observers dependent on field telephones often lost communications when Japanese infiltrators cut wire lines, or found themselves unable to adjust fire rapidly enough to track moving targets. The SCR-300 eliminates both problems. Radio communications cannot be cut by enemy action, and the speed of voice transmission allows continuous adjustment that keeps artillery on target regardless of enemy movement. The Fire Direction Center, coordinating fire from multiple batteries and managing requests from several forward observers simultaneously, demonstrates the efficiency of centralized fire direction combined with radio communications. Captain Anderson's team processes Martinez's adjustments while simultaneously directing another battery to fire on a separate target reported by a different observer, allocates ammunition based on target priority, and maintains communications with battalion headquarters regarding overall artillery support requirements. The system operates with mechanical efficiency that pre-war artillery officers would have considered impossible, achieving coordination and responsiveness that multiplies the effective firepower of each gun. By 0600 hours, barely 12 minutes after Colonel Iwasa initiated his assault, the Japanese attack has effectively collapsed under artillery fire that proved far more responsive and accurately adjusted than any previous experience suggested possible. Of the 200 soldiers in the first wave, approximately 120 are casualties, killed, wounded, or too disoriented by the sustained bombardment to continue coherent offensive action. The second wave, advancing behind the first, encounters similar artillery fire as Martinez shifts targets to engage fresh enemy formations. The third wave, witnessing the devastation ahead, begins faltering as soldiers instinctively seek cover rather than continuing forward into artillery fire that seems to track every movement. Colonel Iwasa, attempting to rally his forces and maintain offensive momentum, confronts the tactical reality that his entire operational plan has been invalidated by American artillery capabilities his intelligence never warned him about. The 5 to 10 minute artillery response time that his planning depended upon has been reduced to under 2 minutes, eliminating the tactical window his rapid assault was designed to exploit. The ability of American forward observers to adjust fire continuously means that movement provides no escape from artillery effects, negating the Japanese doctrine that emphasized speed and infiltration. Most devastating psychologically is the realization that American artillery can respond to threats anywhere within its range with speed that makes traditional Japanese infantry tactics obsolete. The survivors of Iwasa's assault battalion, those able to withdraw under continuing artillery fire, carry stories of American artillery that knows where we are and follows us no matter how we move. Private First Class Hiroshi Tanaka, one of fewer than 300 men from the original 650-man force who survived to reach Japanese lines, describes the experience in his diary. The American artillery found us within minutes of our assault beginning. Every time we moved, the shells moved with us. There was no escaping it, no outrunning it. The shells seemed to know exactly where we were going. Our officers kept shouting to move faster, but speed meant nothing when the artillery tracked our movement perfectly. Lieutenant Hayes, conducting after-action assessment with his platoon as dawn fully breaks, recognizes that his position successfully defended not through superior numbers or better individual fighting positions but through artillery support coordinated with unprecedented speed and precision. Corporal Martinez's SCR-300, the 38-pound radio that made instant communication with Fire Direction Center possible, proved more valuable than any individual weapon system in defeating an assault that might otherwise have overrun thinly held Marine positions. Hayes notes in his report, artillery support was decisive. Forward observer maintained continuous communications throughout engagement. Fire requests answered within 90 seconds consistently. Adjustments processed and implemented within 1 minute. Japanese assault disrupted before reaching assault distance. Estimate artillery accounted for 70 to 80% of enemy casualties. The tactical lessons from the November 1st engagement spread rapidly through American forces as company and battalion commanders recognized that SCR-300 radios fundamentally alter infantry-artillery coordination. the ability to call artillery fire in real time, adjust continuously while observing effects, and maintain communications regardless of wireline status transforms forward observers from specialized positions tied to telephone networks into mobile fire coordination centers that can accompany attacking infantry or defend from any position within radio range. The strategic implications prove equally significant. Japanese forces can no longer exploit communication delays to close with American positions. Defensive perimeters become far more difficult to assault when every rifleman position potentially includes forward observer capability, and American offensives gain artillery support that can respond instantly to targets of opportunity. The tactical analysis of the November 1 Bougainville engagement begins within hours as Marine Corps intelligence officers interview participants and compile after-action reports documenting the SCR-300's decisive impact on defensive operations. Major Thomas Blackwell, intelligence officer for the 3rd Marine Division, coordinates debriefings with forward observers, artillery officers, and infantry commanders, documenting response times that prove revolutionary compared to earlier campaigns. His preliminary report, completed November 3, concludes that radio-coordinated artillery support reduces average response time from initial contact to first rounds impacting from 8 to 12 minutes to under 2 minutes, fundamentally altering tactical calculations regarding assault timing and defensive depth requirements. The systematic documentation of communication timelines provides empirical validation of the SCR-300's operational value beyond theoretical specifications. Captain Anderson's Fire Direction Center maintains detailed logs showing Martinez's initial fire request received at 0553:42, firing data calculated and transmitted to gun batteries at 0554:10, and first rounds impacting at 0554:40, total elapsed time of 58 seconds from observer request to effect on target. Subsequent adjustments show similar efficiency. Correction transmitted at 0555:05, adjusted fire launched at 0555:15, impacts at 0555:35, 30 seconds total for complete adjustment cycle. These documented timelines, compared against earlier operations using field telephone or runner-based communications averaging 5 to 8 minutes per fire mission, demonstrate the multiplicative effect of eliminating communication delays. Japanese after-action analysis, conducted by survivors of Colonel Iwasa's battalion and reviewed by division staff, struggles to explain the unprecedented artillery responsiveness that defeated their assault. Lieutenant Kenji Matsuda, one of few surviving company commanders, reports, American artillery responded with impossible speed. Our planning assumed minimum 5 minutes from detection to first shells, allowing time to close with their positions. Artillery fire began less than 2 minutes after our advance was detected, striking our formations before we reached the halfway point. Subsequent fire adjusted continuously, following our movement as if American observers could see through jungle and direct shells to our exact positions. The strategic implications of radio-coordinated artillery extend far beyond individual tactical engagements to affect operational planning throughout the Pacific Theater. Major General Roy Geiger, commanding I Marine Amphibious Corps, recognizes that SCR-300 distribution fundamentally alters defensive requirements and offensive capabilities. Defensive perimeters that previously required dense concentrations of infantry to achieve mutual support can now be held by fewer troops with greater spacing, the reduced density compensated by artillery support that responds instantly to threats anywhere within radio range. Offensive operations gain flexibility as attacking units maintain continuous artillery support without requiring time-consuming establishment of field telephone networks that Japanese counterattacks often severed. The technical evolution of the SCR-300 from laboratory prototype to combat-ready equipment represents significant engineering achievement addressing challenges that delayed tactical radio deployment for decades. Dr. Alfred Gross, civilian engineer who contributed to the original walkie-talkie concept, worked with Signal Corps engineers to miniaturize vacuum tube technology, develop lightweight batteries providing sufficient power for extended operations, and design antenna systems achieving adequate range without excessive length. The FM transmission system, operating at frequencies between 40 to 48 MHz, required sophisticated receiver designs that could discriminate desired signals from interference while maintaining voice quality adequate for military communications where clarity proves essential for transmitting coordinates and fire commands. Lieutenant Colonel James Harrison, Signal Corps Liaison Officer observing SCR-300 employment in the Pacific, documents both capabilities and limitations that inform training and tactical employment doctrine. The radio achieves reliable 3-mile range in open terrain, but jungle foliage and terrain features reduce effective range to 1 to 2 miles in typical Pacific theater conditions. Battery life supports approximately 8 hours of continuous operation, though actual field usage patterns, with radios powered on but transmitting only intermittently, extend operational time considerably. The 38-pound total weight, 35 pounds for radio, 3 pounds for battery, requires operators to be physically fit and limits sustained movement with the equipment, though soldiers acclimate to the weight through training and operational experience. The integration of SCR-300 radios with existing artillery fire direction procedures required doctrinal development establishing standardized protocols for radio-coordinated fire missions. Field Manual FM 6-40, updated in late 1943 to incorporate radio procedures, establishes brevity codes and standardized formats that allow forward observers to transmit complete fire missions in under 10 seconds. The procedures emphasize clarity and precision. Observers identify themselves using assigned call signs, transmit target coordinates using pre-plotted reference points, specify target type and desired effect, and conclude with over-to-signal transmission complete and await acknowledgement. Fire direction centers respond with acknowledgements, estimated time to impact, and requests for clarification if initial transmission was unclear or incomplete. Captain Martinez, having successfully coordinated the November 1st defensive fires, becomes informal training officer for other forward observers transitioning to SCR-300 operations. His practical experience provides insights that formal training manuals cannot capture: the importance of pre-plotting likely target areas and memorizing reference point coordinates to eliminate map consultation during engagements, the value of maintaining continuous radio contact even when not actively calling fire to ensure communications remain functional, and techniques for describing targets clearly using terrain features that fire direction personnel can locate on their maps. Martinez emphasizes that the SCR-300's technical capabilities mean nothing without operator proficiency. The radio lets you talk to the guns instantly, but you still need to tell them where to shoot accurately and adjust intelligently based on what you observe. The psychological impact on American infantry, knowing they possess instant access to artillery support through radio communications, proves as significant as the tactical capabilities themselves. Private First Class Robert Thompson, rifleman in Hayes Platoon, describes the confidence boost. "Before, we knew artillery was back there somewhere, but getting them to shoot where we needed took forever and usually didn't work during fast-moving fights. Now, Martinez just talks into his radio and shells start landing within minutes. Knowing that support is actually available and will arrive quickly changes everything. You don't feel isolated or abandoned when Japanese attack. You know heavy firepower is just a radio call away." Japanese tactical adaptation to American radio-coordinated artillery proves difficult because the fundamental problem, communication speed enabling rapid artillery response, admits no easy countermeasures. Major Hatanaka, analyzing multiple engagements where Japanese forces encountered SCR-300 coordinated fires, recommends increased emphasis on night attacks when American forward observers cannot observe targets as effectively, greater dispersion to limit casualties from individual artillery concentrations, and attacks from multiple directions simultaneously to overwhelm American artillery's ability to respond to all threats. These adaptations achieve marginal improvements but cannot eliminate the basic advantage American forces gain from compressed response times that Japanese communication systems cannot match. The production and distribution of SCR-300 radios accelerates throughout 1944 as military procurement recognizes the system's combat value. Galvin Manufacturing Corporation, primary contractor for SCR-300 production, increases output from initial hundreds of units monthly to over 50,000 units produced during the war. the industrial capacity to manufacture tens of thousands of complex electronic devices incorporating vacuum tubes, precision components, and specialized batteries demonstrates American manufacturing capabilities that Axis nations cannot replicate at similar scale. By mid-1944, SCR-300 radios become standard equipment for Marine and Army infantry battalions throughout the Pacific, with forward observers assigned to each rifle company and sometimes each platoon in intense combat operations. Lieutenant William Foster, artillery liaison officer with the 1st Marine Division, develops advanced techniques for coordinating multiple forward observers and multiple artillery batteries simultaneously using radio communications. His procedures, documented in division training bulletins, establish protocols for priority of fires when multiple observers request support simultaneously, methods for deconflicting fire missions when observers operate in proximity, and techniques for shifting artillery between targets rapidly as tactical situations evolve. The procedures demonstrate that radio communications enable not just faster individual fire missions but entirely new coordination paradigms impossible with field telephone networks that required physical connections between each observer and fire direction center. The Battle of Peleliu in September 1944 provides dramatic demonstration of SCR-300 capabilities during offensive operations where traditional wire communications typically failed as advancing troops outpaced ability to lay field telephone lines. Forward observers equipped with SCR-300 radios accompany assault companies, maintaining continuous communications with artillery batteries and directing fire against Japanese defensive positions, caves, and counterattacks without any requirement for physical cable connections. Marine Corps after-action reports credit radio-coordinated artillery with enabling advance rates 30 to 40% faster than previous operations, as units no longer pause to establish communications before artillery can support further movement. Captain Anderson, having coordinated hundreds of fire missions using radio-equipped forward observers, reflects on the transformation in artillery employment. Before SCR-300, we fired mostly planned concentrations, pre-calculated missions on likely targets that we set up hours or days in advance. Maybe 20% of our fire was responsive to observer requests, and that took so long to coordinate that targets often moved before we could engage them. Now, 70 to 80% of our fire is responsive, observers see targets and we shoot them within minutes. Artillery has transformed from strategic asset requiring extensive planning to tactical weapon that infantry commanders employ as freely as their own organic weapons. German military observers, analyzing American operations through intelligence reports and interrogations of captured personnel, identify radio-coordinated artillery as significant tactical innovation that Wehrmacht forces struggle to replicate. German tactical radios, while technically sophisticated, remain too heavy and power-hungry for infantry forward observer use, and German artillery doctrine emphasizes centralized planning rather than responsive support to frontline observers. Post-war German military analysis acknowledges that American artillery-infantry integration using portable radios achieved coordination levels that German forces never matched despite their technical expertise. The training pipeline for forward observers expands dramatically as demand for radio-qualified artillery spotters grows throughout 1944. Artillery schools at Fort Sill and Camp Pendleton incorporate extensive SCR-300 instruction into forward observer courses, with students spending weeks practicing radio procedures, coordinate transmission, target description, and fire adjustment. The training emphasizes speed and precision under stress, with instructors creating realistic scenarios where students must coordinate fire missions while under simulated enemy fire, with equipment malfunctions, and with communications difficulties. Graduation requirements include demonstrating ability to conduct complete fire mission from initial contact to effective fire on target within 3 minutes consistently. The human dimension of radio-coordinated artillery, the psychological burden on forward observers who directly cause massive casualties through their transmitted coordinates, receives inadequate attention during wartime but proves significant in post-war analysis. Corporal Martinez, reflecting years later on his November 1st engagement, describes complex emotions. I transmitted grid coordinates and watched artillery tear apart hundreds of Japanese soldiers. It was necessary, they were trying to kill us, but there's something disturbing about the mechanical nature of it. I speak into a radio, numbers that mean nothing by themselves, and men die. The distance and abstraction, killing through transmitted digits rather than direct fire, bothered me more than I expected. The tactical flexibility enabled by radio communications extends beyond defensive operations to revolutionize offensive artillery support. During the Philippines campaign in late 1944, forward observers accompany assault infantry through Japanese defensive lines, continuously adjusting artillery fire to suppress strongpoints, destroy bunkers, and interdict Japanese reinforcement routes. The advancing observers maintain radio contact throughout movement, directing artillery that walks ahead of friendly troops at distances calculated to maximize suppressive effect while minimizing friendly fire risk. This rolling barrage technique, impossible without continuous real-time communications, proves decisive in breaking through Japanese defensive positions that might otherwise require extended assaults and heavy casualties. The integration of SCR-300 communications with advanced artillery ammunition, particularly variable time, VT, proximity fuses deployed in the Pacific during 1945, creates multiplicative effects where improved communications enable employment of improved munitions with devastating effectiveness. Forward observers direct VT-fused artillery against Japanese positions, the proximity fuses ensuring optimal airburst detonation while radio coordination ensures shells arrive precisely where needed. The combination proves catastrophic for Japanese forces, as artillery fire simultaneously becomes more responsive, through radio coordination, and more lethal per round, through VT fuses, creating firepower effects that Japanese defenses cannot withstand. Japanese prisoners interrogated about their experiences under American artillery consistently emphasized the psychological impact of fire that responds impossibly quickly and adjusts with apparent omniscience. Sergeant Takeshi Yamamoto, captured on Okinawa in April 1945, describes the terror: "You learn to fear American artillery above all weapons. It finds you within minutes, no matter where you hide or how you move." We would attack thinking we had time to close with their positions before artillery responded, and shells would begin landing almost immediately. The Americans seemed to know exactly where we were at all times, directing their guns with precision that seemed supernatural. We came to believe they possessed some technological means of seeing through jungle and darkness. The technical limitations of the SCR-300, its weight, battery life, and range restrictions, receive continuous engineering attention as Signal Corps researchers work to improve performance while maintaining portability. Later variants incorporate improved battery technology extending operational time, antenna modifications increasing range, and component miniaturization reducing weight. However, the basic FM radio design remains relatively unchanged throughout the war, suggesting the original engineering achieved near optimal balance between conflicting requirements of range, weight, power consumption, and voice quality given available technology. The post-war analysis of American artillery effectiveness in the Pacific quantifies the SCR-300's contribution through statistical comparison of operations conducted with and without radio-coordinated fire support. Studies document that units equipped with SCR-300 radios achieve 300 to 400% higher rates of responsive fire missions compared to units relying on field telephones, complete fire missions 60 to 70% faster on average, and report 40 to 50% reduction in artillery ammunition expenditure per enemy casualty, reflecting improved accuracy from rapid adjustment. The economic value, measured in reduced casualties, faster operational tempo, and more efficient ammunition use, far exceeds the SCR-300's procurement and operational costs. The legacy of radio-coordinated artillery extends far beyond World War II to establish doctrinal foundation for modern combined arms operations where instantaneous communications enable integration of fires, maneuver, and intelligence that would be impossible with slower communication systems. Modern forward observers using digital communications, GPS positioning, and computer-calculated fire solutions operate on principles established when SCR-300 radios first demonstrated that eliminating communication delays fundamentally transforms artillery from area weapon to precision-responsive fire support. The conceptual breakthrough, that tactical radio enabling real-time coordination proves more valuable than incremental improvements in gun range or shell lethality, shapes military communications development for subsequent decades. Captain Hayes, promoted to major and serving as infantry tactics instructor at Quantico after completing his Pacific tour, incorporates lessons from radio-coordinated artillery into Marine Corps doctrine that emphasizes integration of fires and maneuver. Combined arms team where riflemen, machine gunners, mortarmen, and forward observers function as integrated system rather than separate elements. The forward observer with SCR 300, in Hayes' teaching, represents force multiplier that extends infantry companies' effective firepower from organic weapons, effective to 500 yards, to encompass entire artillery range, up to 11,000 yards for 105 mm howitzers, transforming every infantry position into potential fire coordination center. The story of the SCR 300 walkie-talkie ultimately transcends its technical specifications: 38 pounds of electronics, 3-mile range, 8-hour battery life, to represent philosophical transformation in military communications emphasizing decentralized execution enabled by centralized resources. The radio freed forward observers from physical tethers of field telephone lines, allowing them to move with assault troops while maintaining instant contact with artillery batteries. This mobility, combined with elimination of communication delays that previously required minutes to transmit fire requests, created artillery responsiveness that Japanese forces could neither anticipate nor counter. Colonel Iwasa's battalion, destroyed by artillery fire that arrived impossibly fast and adjusted with uncanny accuracy, learned through fatal experience what American forces already understood, that communications technology enabling real-time coordination proves as revolutionary as weapons themselves, that reducing response time from minutes to seconds fundamentally alters tactical calculations, and that industrial capacity to mass-produce sophisticated electronics provides decisive advantages. That courage and tactical skill cannot overcome. The voice that summoned thunder in seconds, transmitted through 38 pounds of radio equipment carried by Corporal Martinez, represented more than improved communications. It embodied the American approach to warfare that emphasized technological solutions, industrial production, and systematic integration of capabilities into combined arms teams that proved unstoppable not through superiority in any single dimension but through synergistic effects of multiple advantages operating simultaneously.